stationary point. Okay. Turning point. Or max or minimum point. Okay. So there are a couple of steps you have to follow to do that. First step step one is find dy by dx. Should find what?
dy by dx.
Dx. Step two, solve these equations. Solve dy by dx is equal to 0. Get it? For x. Solve for x. You will find dy by dx first and then equate that to 0 and then find the x coordinate. All right. That will be what? The turning point x coordinate or the stationary points x coordinate or maximum minimum points x coordinates. Now you may have a confusion. You see here, if you have a graph like this, for an example, okay, you have an equation and you just differentiate it. Say y is equal to f of x. So this graph has a maximum and a minimum, right? You see that the maximum is somewhere here. Minimum is somewhere here, right?
Yeah.
Minimum x coordinate of the minimum. Here's the maximum. We can also call this a turning point. The graph turns. That's why it is. You see all the points, all the names.
Yeah.
Now here, if you just equate the curve's equation of this one to 0 and then solve for x, how many x values you will get? 2.
Yeah, because we have two turning points.
Yeah, two turning points or maximum minimum points. One is maximum, the other one is minimum. We got 2. So how do you know that? Which one's answer? Which one is the maximum's x coordinate? Which one is the minimum's x coordinate? Do you see that?
Yeah.
So there we have to follow another case, which is another theory part, which is for justifications. Justification means, what is the meaning of that one? We just prove whether it's a maximum or minimum.
Okay.
That's another steps. There are 2 more
So
steps.
right below minimum, you wrote something. X is what?
Now x coordinate, okay?
X coordinate.
X coordinate. Justification step is, the step 1 is, you find the second derivative. D squared y over dx squared.
Okay.
Okay?
Yeah.
D squared y over dx squared. So we need to decide, suppose you got 2 answers, x1 and x2 here.
Yeah.
Whether x1 gives a maximum or minimum, whether x2 gives a maximum or minimum, we have to decide it.
Yeah.
So in the second derivatives expression or the
Yeah.
equation, substitute the x coordinates, which you need to prove whether there's a maximum or minimum. For an example, if you got x equals 5 here, you just substitute x equals 5 into the second derivative's answer.
Okay.
And then you will get an answer, right? After, say, for an example, the second derivative is 2x minus 5. If you substitute
Yeah.
x equals 5, if you substitute x equals 5, you get an answer
5.
minus 5.
Yeah.
Get it?
Yeah.
Right. So based on the answer,
-5.
minus 5, right? X equals 5.
So if x equals to 5, won't it be 10 minus 5? So it should be 5, right?
Yeah, just plus 5. You're right. Plus 5. So based on the answer, we just decide with the maximum or minimum. This is the theory part, right? Now, if d squared y over dx squared is more than 0, it's a what?
Okay, if it's more than 0, it's going to be minimum graph.
Minimum.
Yeah.
I mean, if the answer you get here is more than 0, it's a minimum points x coordinate. Okay. If the second derivative answer is less than 0, it's a maximum points x coordinate.
Yeah.
Right?
So basically, if it's a positive value, it's going to be it's going to be a minimum. If it's a negative value, maximum. Just like how we. Yeah.
Yes.